let's see. 2015, day 23. Opening the Turing lock. Little Jane Marie just got her very first computer for Christmas from some unknown benefactor. Manual explains the computer supports 2 registers and say, oh, okay, we're making a VM. Nice. Registers are named A and B, can hold any non-negative integer, and begin with the value of 0. We have Holf, sets register to half its current value. We have Tipple to triple, Inc, increments. Jumps. G is like jump, but only jump if register R is even. And Geo, if only jumps if register R is 1. Jump if 1, not odd. Okay, all 3 jump instructions work with an offset relative to that instruction. The offset is always written with a prefix plus or minus to indicate the direction of the jump. For example, jump plus 1 would simply continue with the next instruction, while jump plus 0 would continuously jump back to itself forever. Okay, program exits when it tries to run an instruction beyond the ones defined. For example, this program sets A to 2 because Jiao instruction causes it to skip the Tipple instruction. So Inc A increments it to 1, Jiao A plus 2. It is 1, so we jump to 2, and Inc A. Okay, what is the value of register B when the program in your puzzle input is finished executing? Okay, let's get input 2015-23. Oh, I fixed up my get input thing, so it just dumps it directly to the file. And we can take a look, make sure I got the session key correct. I see a plus 22, a plus 19, an 8 and a 4, a 2 and a minus 7. Oh, I see. I was looking at saying this is all A business. So it only increments B if A is 1. Oh, if A is not 1. Because if A is 1, then it skips 8. 1, 2, 3, 4, 5, 6, 7. Oh, it ends. Interesting. That's weird. Here's a jump plus 2 is also exits, right? 1, 2. Oh no, jump plus 2 goes jump minus 7. 3, 4, 5, 6, 7. Increment B, jump if even plus 4, 1, 2, 3, 4. Divide by 2. Oh, okay. So we have some setup code, right? I'm not sure what this is going to do. And then a little more, it might skip over this. Maybe that's going to be for part 2. And then we have this little loop here, which calculates a number and increments B each time. Okay, so I think I understand what's going on. We do need to write a parser and have these instructions. So let's dive in. Mod. We're almost done with 2015, aren't we? And then maybe I can get back to my roguelike for a little bit and then start on 2016. Mod day 23, comma. Okay, and then this over here, I'm running Clippy. (2015) day 23. Make sure that runs. Oh, I forgot to rename it. Yeah. Like that. Okay. So now if we run it, it should say unsolved. Good. Okay, so first things first, let's set up a VM. We have different instructions. So enum instruction, and we'll say Holf. Should I do it that way, or should I do it the full word? I'll just do it this way. That way they all line up. And then we're going to do a register. And that only does registers. And then the jump instructions take offsets. So should I make the register an enum also? AB. Oh, there's no semi there, right? So register. We have tuple register. We have inc register. We have jump offset. It's just I32. G register offset. And we have geo register offset. So that should be register. There we go. So now we just need to figure out how to parse the input. So for each line, let's pull up the input here. Oh, what's this? How do you turn off the syntax? Nope. And vim disable syntax highlighting. Syntax on. Okay, so I can just say syn off. Oh, that turned it off in the wrong buffer. Oh, this is probably like spell checking or something like that. Syn on. So it turns it off with everything. Disable spell check. Auto disable spell check. How to disable spell highlight. Filter spell. Set spell. Do I say just say no, set no spell? There we go. Okay, now I can read it. So now what we do is for line in AOC lib read lines input 2015-23.text. I'm going to split on space. Split once on space. Let mnemonic and the rest is equal to line.split once. Do I need to unwrap it? Yeah, okay. And now we can just match on the mnemonic. We say JO. Oh, let's just do it in the same order. HLF. And that's going to be something. Right, we have TPL. Inc, jump, there we go. Inc, JMP, JE, JO. Right, that's everything. And then this is just panic bang input file corrupted. That works for me. Does that work? We have 4 warnings. Good. Okay, so now all we're going to do is, this will be the instruction. And what we're going to do is create the instructions here. So we'll say program is a vec of instruction. How does that look? And then here in new, where's new? Here it is. I just say self program vec new. And I forgot to finish things here. So this needs a semicolon. Oh, wrong line. And it would just say self program push inst. I could just push the match statement, but this, I think, is easier to read. It doesn't like that. Oh, because we're not returning anything. Okay, so now we have to return instructions. So this is just instruction : HLF. And now we have to figure out which register we're in. So if it's jump instruction, it's going to have a comma in it, and we'll have to split that apart. These first 3 will have a register, and then this one's just going to have the offset. Okay, so we can create a little helper function here. Fn reg of stir register match s, a returns register a, b is register b, and everything else is a panic. Input file corrupted. And then down here we just say self reg of rest. Right? I think that's all we need to do. And then this is the same thing except TPL. TPL. And then inc. Right? And then jump is going to take the offset. So it'll be instruction JMP rest dot parse. I wonder if it can figure out, because JMP takes a U and I32. Oh, we don't want commas here, right? And then what we can just do is put these in here. Just to get it to compile. I want to see if this will compile. Oh, okay, that's even nicer without the braces. The auto format. It doesn't like that. No method named reg. But it's right here. Okay. Oh, this is an associated function, not a member. Okay, yeah. Self. Like that. There we go. Okay, that's good. We have 3 warnings that we're not generating those. Okay, that's fine. What's next? So this will be JIO. Oh, we have to split. Yeah, so these will be interesting to handle. Can I handle them up here? I probably could, right? Because what does split once do if it can't find anything? It'll just ignore it, right? So reg and offset is equal to rest dot split once comma space unwrap. And that way we have them for here, and we can just say this will be G, and this will be JIO. That'll be register, and then that'll be register on reg. And then we have here the offset, rest parse. No, not rest, offset parse unwrap. Oh, gotta call it. Okay, so now we should be able to print that out after we're done. Let's see if we can actually print in debug mode. Oh, and I have to add debug to those guys. Self program. Here, please ignore the train in the background. Derive, debug. Like that. All right, and if I run this, it panicked. Let's see, what line? 47. Oh, if it can't unwrap it, so this would be unwrap or. Empty string. There we go. All right, so did we get it right? JO A22, inc A, tipple A, tipple A, tipple A, tipple A, blah, 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 blah. Then there was a jump 19. Yep, right there. And then what else? A bunch of tipples after that. We do have an inc A in there. I do see the JO8, Inc. B, JE. So I think we've got it, right? There's even the negative jumps are working fine. So, okay, that was relatively easy to do. Now we just need to execute it, right? We'll start a machine. Instruct a machine, which is going to have an A register, a B register. Oh, I don't know if I don't know what they're going to do, how high it's going to get, but we'll see. We'll start with I32, and then we can always bump it up if we need to. And then the instruction pointer is usize, because it's going to be indexing into program. And then we're going to just throw the machine in here. Machine. Machine A0, B0, IP0. Oh, it's just machine, and in our new, that's where we have to put it. Yeah, that should build, and it should tell us that machine's not being used. And now, instead of doing this, we'll just run the machine. We don't, oh, we need that. We don't need that. Okay, so now we just say run. Self machine run. And then we just give it B. Self machine B. What's in the, right? It said what's in the B register? It's a value in register B when your puzzle input is finished executing. Perfect. We might have to write something to reset it for part 2, but that's fine. And then we're going to impl machine. Oh, if machine's going to run, or maybe we should make the run here, because this has access to the machine and the program. All right, so we'll just say self run. It's a little sloppy because the machine actually should have a pointer to the program if we're going to do it the right way, but we're not doing it the right way. We're doing it the expeditious way. Run self, mut self, right? Because we're going to modify, and it's not going to return anything. So while self machine IP, I shouldn't have called it machine if I can't type machine properly, is less than self program len. Right? They said when to exit, program exits when it tries to run an instruction beyond the ones defined. So that's when it's going to exit. We're going to say match on self program, self machine IP. And then we'll just execute each one of these guys. How hard could that be, right? Instruction, colon, colon. And this will be, for each one of these registers, it'll be R, R, R. This will be R and R. And then these guys will just be offset. And then we say, what do we do here for register R? Oh, this is going to be awkward, isn't it? I'm thinking, okay, I want to just set A and B based on it if it's A or B. Right, but then it means every single one of these is going to have to say if R is equal to, and I have to put a partial equal on it, right? Register A, then we're going to half register A divided self dot A divided by equals 2, and that'll compile it into a shift instruction, and then we can just change all of these guys to do nothing, right? Yeah, we need to add partial equal. Oh, machine A. Right, so oh, consider borrowing here. I'll borrow. I'm happy with borrowing. I could do that too. Yeah. Or I could say star R, right? Else self machine B divided by equal 2. We don't actually have that instruction, but that's okay. And then we have to do that for each one of these guys, right? For triple, if star r is equal to register, it would have been nice to have it as an index instead, right? Self machine A times equals 3, else self machine B times equals 3. That works, okay. I don't know if it works. I'm not writing tests for any of these, am I? Register A, self machine A plus equals 1, else self machine B plus equals 1. Now jump. So jump is going to be the offset. Oh, right. And the other thing I need to do is increment IP if we haven't jumped. So we could just slap that in here. Self machine IP plus equals 1. It's a little lazy, but so then we say jump offset. So this is self machine IP plus equals offset. Oh, as usize, because offset is an I64, I32. Okay, and then we want to say let test equals if R equals register A. Let's say value. Machine self machine A, else self machine B, okay, and then we say if it's even, then we're going to jump to the offset. If value mod 2 equals 0, self machine IP plus equals offset as usize. Oh, that's not going to work. That is not going to work. Okay. Because we have to be able to do negative. Oops. I just punched the microphone. This is not going to work. I have to say if offset is less than 0. How do we do this? Because I want to subtract the negative offset. We can do it this way. Plus equals. Oh, no, I can't. So I have to say self machine IP minus equals offset negative offset as usize. Else. This is very awkward. And if it's positive, then we can just do that. And then we have to do that for each one of these guys. So let's just make a general purpose instruction. Self machine jump offset. And then I'll just put that logic in one spot. Self machine jump offset. Else, we're just going to increment it like we do all the other instructions. And then the same thing with if it's 1, right? We'll take this here and copy it there. And then we can say, instead of value is 0, value mod 2 is 0, we can say if value is 1, then we'll jump on the offset. And I probably should test each and every single one of these, but I'm too lazy. Okay, so in machine, implement machine, we're going to implement a jump itself. And we're going to basically, we're going to take in the offset of I32. And yeah, that means we have to change all the I32s if we go over, but that's okay. I'll change it to a different type at that point if we need to. So now if offset is less than 0, then we're going to say self IP minus equals negative offset as usize. Else self IP plus equals offset as usize. Let's see if that builds. It does not. Expected I32 found I32. Okay. That's easy to fix. Huh. All right. So should we just run it? See what happens? What do we have here? It says 255. That seems wrong. But let's try it. That is the right answer. Wow. That was quick. All right, so what's part 2? Part 2 is blow everything up. The unknown benefactor is very thankful for helping little Jane Marie with her computer. Oh, released something. Definitely not to distract you. What is the value in register B after the program is finished executing if register A starts as 1 instead? I've got a feeling that's going to be like it runs forever, so we have to come up with a better solution. But we can try it. And yes, we do need to do a reset. Self machine reset. And then self machine dot, if register A starts as 1, self run. And I'm going to take this off of run in case this is like an infinite loop here. I've been caught too many times with that. And then we just print out B here. Self machine B. And I can change this apparently on line 123 to just a character instead. We don't have reset yet, but we will. Give me a second. FN reset, self, and it's just self IP equals 0, self A equals 0, self B equals 0. Okay, so now we're going to try running it. Cargo run. Release. That's probably going to take forever. I'll let it run for maybe 10-15 seconds, and if it doesn't sort it out, then we'll have to take a look at the code itself. No. It did something. Huh. Okay, that was suspiciously easy. All right. But we did parts 1 and 2 at the same time. Git add input source git commit 2015 day 23 parts 1 and 2. All right, that wasn't too bad, and we're almost done. One of the things that's true every year is that part 25 or day 25 is there's a single puzzle, and then part 2 of the puzzle is solve all the previous puzzles, which we will have done. So there's only 3 things left to do. There's 24 part 1, 24 part 2, and then 25. So I'm going to save those for the next stream. I don't know how long it'll take to do